Hello, my name is Hadi. I was watching the stars because today our topic is space-time. This is why I was using my telescope to watch the stars. I'll start explaining from Aristotle to Einstein. Around 350 BC, Aristotle introduced his theory of falling objects that heavier objects fall faster than lighter ones. He says, for example, if you have a 10-pound object and a 1-pound object falling from a tree, the 10-pound object would supposedly fall the difference in its mass relative to the smaller object. So that means that the 10-pound ball would fall 10 times faster than the 1-pound ball according to Aristotle's theory. But in 1590, Galileo proved this wrong by using the Leaning Tower of Pisa to conduct an experiment. He says if you drop two objects from this tower with a noticeable difference in mass, let's say one's 10 pounds, one is 2 pounds, then the 10-pound ball would fall 5 times faster than the 2-pound ball according to its difference in mass. And I will now show you an experiment. I have two bottles. One is empty, this one, and one is full, this one. I will now drop them. Galileo said they land at the exact same time. He was almost right. They land at slightly different times due to air resistance, which sometimes slows down the smaller or lighter object, which in our case was the empty bottle, a bit. Later, around 600 years after this, in NASA, they used a vacuum room to drop a metal ball and a feather. And when they did this, they found out that they would fall at exactly the same time. In the 16th, Isaac Newton, after the apple fell on his head when he was sleeping, which is the incident that motivated him to discover gravity, he realized that it's the same force pulling apples to the ground and pulling planets together. And this later evolved to the string theory. But Newton also discovered that the motion of objects is relative to the observer, as he said in his theory of Newtonian relativity. You have two trains moving in opposite directions at the same speed. Let's say that constant speed was 40 kilometers per hour. They would see each other going at 80 kilometers per hour, but in the opposite direction. And he said that there is no such thing as absolute rest or absolute motion. Since Newton did not do any experiments about the electromagnetic forces, he couldn't discover that the speed of light is a constant. Until in the 19th century, when James Clerk Maxwell did his most notable achievement, which was that the speed of light moves at a blitz 186,000 miles per second, independent of the observer. Here, the genius of our time, Albert Einstein, thought that he had to choose between light isn't a constant or Newtonian relativity was incomplete. As per Maxwell's theory, he said light is a constant. But if he said light is a constant, he would be contradicting Newton, who said there's no such thing as a constant speed. And the other possibility was that the two notions could coexist with a small tweak of Newton's laws. He called this absurdity time dilation, and I will now explain how he discovered his newfound theory of special relativity. There were 5 formulas in this theory. The first one known to us was the length contraction, which was L prime equals L 1 minus V squared over C squared square root. L prime is the length after the contraction of the object. L was the original length of the object, V was the object's speed, assuming it was constant, and C is the speed of light. The second one was the mass increase with acceleration. So, this formula states that classical physics used to say that mass never changes, it is constant. This is what classical physics used to say. But Einstein said that mass changes with acceleration. So it depends on how fast you're moving, your mass becomes heavier. And there was a formula for this. He created the formula m prime equals m over 1 minus v squared over c squared square root. M prime is the increased mass of the object after it has went at a super fast speed, and m was the original mass of the object. And in 1952, in Brookhaven International Laboratory, they could reach with a proton up to 95% of the speed of light. And according to Einstein's formula, its mass increased by 3 times. However, in the California Institute of Technology, also known as CIT, they reached 99.9% of the speed of light, and its mass increased by 900 times. This is our second formula. Our third was the formula of combined velocities. In classical physics, they used to say that an object traveling at 100,000 miles per second and another traveling at the same speed in the opposite direction, they can't see each other going at 200,000 miles per second, because that's just wrong. Because light is the cosmic speed limit of the universe. That's all around us. So if light's the cosmic speed limit, how can we see an object moving faster than light? Einstein knew this formula had to be changed, and he changed it to velocity is v1 plus v2 over 1 plus v1 times v2 over c squared. And the fourth formula, E equals mc squared, energy and mass. Einstein knew that each mass has an energy, and each energy has a mass, and they were both aspects of each other. So he developed the theory how much energy there is in a given amount of mass, which was E equals mc squared. So a small amount of mass could give a huge amount of energy. And Walton and Cockcroft in 1932 used this by using the lithium atom, the proton, and a particle accelerator to smash these two atoms together. But the lithium atom broke apart, and it lost some mass. This lost mass produced E, as we will now call it, which is energy, as Einstein says. It produced a huge amount of energy. This led to the development of the A-bomb, or the atomic bomb as we know it. And we previously learned that space-time is the fourth dimension, because after Einstein showed us the distance contraction, the length contraction, and time dilation, it is clear that space-time has to be the fourth dimension. So, now we have the last formula of this theory, time dilation. My living can be different from your living if I'm traveling at the speed of light. So, Einstein gave his formula of time dilation, which was the last in his theory. T prime equals T 1 minus v squared over c squared square root. T is the time for the stable object on Earth, and T prime is the time after it is dilated by the object's speed. 10 years after this theory, Einstein published his second theory, which was called general relativity. So we have special relativity and general relativity. General relativity was the point when Einstein started to think of space-time as a fabric. This fabric, as much mass was placed on it, it would bend the fabric around it. This is how he viewed gravity. When he discovered light was the cosmic speed limit of the universe around us, he found himself contradicting Newton. But how? I'll give an example. Let's take into consideration our sun vaporizes without any warning. According to Newton, the planets would fly out of orbit as soon as this happens. But this means, isn't gravity faster than light? Well, that's wrong, because Einstein just proved that light has nothing faster than it. It's the speed limit. So, Einstein said that instead of Newton, he would say that According to his calculations, light and gravity, their speeds are equal. So when the last of the light reaches us from the sun, which takes about 8 minutes, only this means what Einstein says holds true. And this shows when the sun vaporizes, these ripples, which also hold true, as Einstein said, would only make us fly away when they pass us. After all I have mentioned about gravity, light, Newtonian, special, and general relativity, there are new questions that have arisen. Some are. The first thing I've found is that photons and light don't experience time at all. These are some questions that have risen in my mind. Is there such thing as zero gravity or zero speed? If there was a man moving close to the speed of light, wouldn't we experience his future and him our past? And finally, will a new genius solve this problem, or will it stay hidden forever?